This video is going to look at substituting values into a basic equation to solve a working equation for a different value. Here we want to solve for v given f equals m multiplied by v squared divided by r when f equals 35,000 newtons, m equals 2,500 kilograms, and r equals 28 0/10 of a meter. First, we are going to write the basic equation for centripetal force in terms of v. To do this, we first will multiply both sides by r. This cancels off the r on the right-hand side, and we are left with f multiplied by r equals m multiplied by v squared. Next, we will divide both sides by m. This will cancel off the m on the right-hand side, leaving v squared is equal to f multiplied by r divided by m. Last, in order to get v by itself, we need to take the square root of both sides. Taking the square root will cancel off the square on the v, so we are left with only v on the right-hand side. The left-hand side will be plus or minus the square root of f multiplied by r divided by m. We need both the positive and negative values because in our original equation, v could be positive or it could be negative. Since we are squaring it, we get the same value for both the positive and the negative root. Now that we have our equation set, we can substitute in the data we are given. This means v is equal to plus or minus the square root of 35,000 newtons multiplied by 28 0/10 meters divided by 2,500 kilograms. When we perform the multiplication, we're left with v equals plus or minus 19 8/10 meters per second. However, since the initial value for mass, 2,500 kilograms, only has two significant digits, our answer can only have two significant digits as well. This means v is equal to plus or minus 20 meters per second. This concludes our example of rearranging a basic equation for a different value and solving given the other data values.